Hi, today we're going to do lesson 3.8, problem numbers. We're going to do number 8 from the homework, which the directions are in the book still, and we're also going to do number 12. So let's go ahead and start with number 8. The directions in the book say solve each equation analytically for all complex solutions. Give exact forms in your solution set. It also says some stuff about graphing and supporting. We'll get to that after a while. If we're going to solve this problem, one thing we have to recognize is this is quadratic-like. If you square x to the second power, you get x to the fourth power. This has some similarities to, a quadratic, which can be solved with quadratic formula and factoring and things like that. What I'm going to do is I'm going to make a little substitution here. This is just one way to solve the problem. I'm going to say let u equal x to the second power. What this is supposed to do is make this a little simpler. Instead of having an x to the second power here, we're just going to have a variable which is u to the first power. But that also means that if u is equal to x squared, that u squared, if I square the left side, then the right side is going to be x to the fourth power. And I'm going to make a little substitution here. Instead of writing x to the fourth, I'm going to put in u to the second. Instead of putting in x to the second, I'm going to put in u to the first. So we're going to have a new problem that says 4u squared minus 29u plus 25 equals 0. And we're going to solve this problem. You have a few ways to do this. You can use the quadratic formula always. You can try to factor it. I'm going to go ahead and try to factor here. I'm going to use a little trial and error. See if I can come up with this. The signs for a positive have to be either positive, positive, or negative, negative when multiplying. Since I need a negative in the middle, this would have to be negative, negative. I need two numbers to multiply together to make 4u squared. 2 and 2, 4 and 1. I'm noticing that 4 and 25 add up to 29. So one of my choices here, I'm going to say 4u and 1u. And I'm also going to say 25 and 1. Now I don't want to put 25 here because 25 times 4 would give me all the way up to 100 already. I'm going to put the 25 here, and I'm going to put the 1 over here. And then the outside is negative 4u, and the inside is negative 25u, which adds up to negative 29u. By the zero product property, this 4u minus 25 must equal 0. Or the other factor, which is u minus 1, must also equal 0. If you solve both of these equations, 4u equals 25, divide by 4, u turns out to be 25 divided by 4. Over here, u turns out to be positive 1. Remember, we weren't solving for u. U is not part of this equation up here in black. It's not part of it. It's x. Well, we said u represented x squared. So I'm going to put x back into the problem now. I'm going to say instead of writing u, I'm going to say x to the second power is equal to 25 over 4. And over here, x to the second power is equal to 1. We have two equations to solve. Both the equations have a degree of 2, which means there are two solutions to both equations, which will total up to 4. And that's going to give us the 4 solutions we'll need for this equation. Now I'm going to go ahead and change colors here because we know that a square root will cancel out a square. And when you're taking the square root, you have to do plus and minus. So x turns out to be plus or minus, and look at that. These guys are perfect squares. The square root of 25 is 5, and the square root of 4 is 2. Look at that. We got two solutions. We got positive 5 halves and negative 5 halves. Over on this one, we're going to do the same thing. We're going to square root both sides. We're going to do plus and minus, and x turns out to be plus or minus 1. So you got two answers over here, which total up to 4. And we have done the solution. We have figured out the solution to this equation. In the book, it also says that you are supposed to be checking this with the graphing calculator. So what I'm going to do is I'm going to start up my graphing calculator, and I'm going to go to the y equals screen, and I'm going to clear out whatever's in there, and I'm going to go ahead and type in 4x to the second power minus 25x squared. I'm sorry, 4x to the fourth power. Let me back that up for a second. 4x to the fourth power, and then minus 29x squared. And then we also have plus 25. Now remember, if the equation is equal to 0, now I'm going to hit zoom 6. If the equation is equal to 0, then we should be seeing on the x-axis where the y coordinate is 0. And that should happen at the zeros that we found. I'm going to zoom in just a little bit more. I'm going to go to this little zoom button here, and I'm going to cut off some space on the left, and I'm going to cut off some space on the right, just so we can see it a little bit more clearly. How about -4 to +4? So the x-min, x-max, I'll change those. I'll hit graph, just so we can spread it out just a little bit more. Now, I don't have a whole picture of the graph. It does go down, and it comes back up. But I do notice that it crosses here at +1, crosses at +1. All right, one more time. We did find that the zeros that we found for the equation were 1, and we also said they were -1. And the other ones were 5/2 and -5/2. Well, 5/2 is 2.5, and that's right between, +2 and +3, and right between -2 and -3, which it crosses. So just looking at the graph, on the calculator, just supporting our answer, we know that that equation is correct. Okay, so I'm going to go ahead and fast forward this now to the next problem, which is number 12. On number 12, again, we're going to be solving analytically, and I am going to be looking at this and analyzing how many terms we have. It looks like we have 4 terms. A lot of times we get 4 terms. You got to think factor by grouping, because you got to solve. We got 3 zeros that we have to find in this particular question. What I'm going to do is rewrite this problem, and I like to write it so that there's a plus sign in the middle. So I'm going to give this 100 its negative sign. Whoops. Sometimes my little wireless board does this, so let me go ahead and fix that. I didn't change the problem at all. It's still the same question. I just made it plus negative instead of minus 100. I'm going to change colors. Now I'm going to try grouping the first 2 terms and the last 2 terms. I'm going to factor out the GCF out of the first 2 terms, which looks to be an x squared. What's left over? X to the third divided by x squared is x. We still have a 6, and the x squared has been factored out. So we're left with x plus 6. And the second one, I notice there's both negatives here. So I'm going to pull out a negative, okay, so it turns to positive. But I also see that 100 goes into both of these. So I'm going to pull out a 100, factor it out. And we're left with a positive x. And it's going to we pulled out the negative, so we're going to be left with a plus sign. And then 600 divided by 100 is 6. So notice that you have 2 factors here. This factor multiplied together and this factor multiplied together. And I say the term factor. It's not technically a factor of the original polynomial, because there is a minus sign separating these, which means this polynomial is not factored yet. But of these 2 terms, there is an x plus 6 that's in common. It's its greatest common factor. We're going to pull the x plus 6 out to the front. We're going to factor it out. What's left? Well, there's an x squared, and there's a minus 100. And that's set equal to 0. All right, so now these are 2 factors multiplied together. By the zero product property, we can say x plus 6 is equal to 0, or x squared minus 100 is equal to 0. Solving both these equations, this little equation, moving the 6 across, it becomes -6. So that's going to have to be one of our zeros that we found. And then we also have x squared, which is going to give us 2 zeros, but it's going to be equal to positive 100. I'm going to change colors here. It always looks nice to put those square root signs in there in different colors. Got to have plus and minus to get our 2 solutions. And x turns out to be plus or minus 10. Now, just like we did last time, I'm going to go ahead and go back to the graphing calculator real quick, and I'm going to type this in and see if we came up with the correct zeros. So I'm going to clear that out, and we had x to the third power, and it was plus 6x squared and minus 100x and minus 600. I'm going to go ahead and hit zoom 6, zoom standard. And I'm going to, this is kind of really spread out here. This is a snake graph. We're not seeing the entire piece of it, but I'm going to go to the window and say, let's go past negative 10 and past positive 10 and just take a look at this really quick. How about negative 15 and positive 15, just to look out a little bit farther. Now the answers we got an answer of negative 6, which you can see, this is negative 6 right here. We also got a negative 10, and we got a positive 10. Now that proves that the graph is done. I just wanted to do one more thing just to show you that you can go back to your window, and you can even tell the graph to go down farther. I can say, let's go down to negative, I'm not sure, let's go down to negative 50 and take a look at it. Okay, I'm going to say graph just at negative 50. I'm still not even reaching the bottom of the graph here for negative 50. I'm going to come back to here. How about negative 100? Is that too far? Let's try it out, because we're not seeing the whole graph. We're still not seeing it. How about negative 300? And hit graph. Still not seeing it. How about negative 500? And graph. I just want you to see that you can change the window button to fit the graph that you're looking for. I'm going to jump out to negative 1,000. This thing's going down pretty far. Oh, look at that. We're finally starting to see it. And you can also see that you can also switch it to see the upper part of the graph for the max. And I can say, what if we go up to 200? Ah, look at that. So you can see that the snake graph, it's up to the right, down to the left, but we already looked at where it crossed, and because it crossed the x-axis at positive 10, negative 10, and negative 6, we know we have those solutions correct, and that would end these two problems that we're doing in lesson 3.8.